What is absorption? Absorption is a physical or a chemical phenomena or process in which molecules, atoms, or ions they'll enter some bulk phase. So it could be a liquid or a solid material. So what are absorbers? Absorbers, they use aqueous scrubbing liquids to remove gases and vapors. So now absorption would thus be referred to transfer of gaseous components from a gaseous phase to a liquid phase where they would be arrested and then removed from the system, and the clean gas can be released to the atmosphere. Absorption occurs into liquid droplets which are dispersed into gas stream, sheets of liquid covering packing material, or jets of liquid within the vessel. So over here, the liquid surface area available for mass transfer and the time available for diffusion of the gaseous molecules are going to be of prime importance, because the contact time as well as the amount of transfer taking place will decide the efficiency of the methodology. Now the diagram over here tells about a conceptual sketch of absorption into droplets. So here if you see, there are these gas phase turbulent mixing taking place. So you have got particular number of gaseous molecules, they are getting absorbed over here into a liquid phase system, and there are certain combinations happening. So this is possible because the adsorbing liquid or the scrubbing liquid is able to trap the molecules or the dirty gas which is there, and the final product would be release of clean gas. So the gaseous contaminant being absorbed has to have certain criteria, that is it must at least be slightly soluble in the scrubbing liquid which is your absorbent. Mass transfer to the liquid will continue until the liquid will approach a particular saturation level. Once the saturation level is approached, then equilibrium will be established. That is, no further visible change or notable change would be there, as the mass transfer rate of contaminant into the liquid and the mass transfer rate of the dissolved species back into the gaseous phase would be equivalent. Accordingly, the solubility of the contaminant is going to create a limit to the amount of the pollutant removal that can occur within a given quantity of liquid. So that is why it has been clearly mentioned that if the solubility is good, the final results would be good. Obviously, there are other factors also which have to be taken care of. Now, this particular solubility factor can be overcome by providing reactants in liquid phase that react with the dissolved gas contaminants, and these dissolved compounds would remain arrested in that form and cannot leave the liquid easily. Then the final output would be good. The use of reactants is very common in absorbers used in this particular technology. So which gives you an overview of absorption as a technique. Now coming to the types of absorbers used. So there are various absorbers. The first being the spray tower absorber, which is a simple technique, followed by packed bed absorbers, tray tower absorbers, and venturi and ejector absorbers. So here is a diagram of a spray tower absorber. Now here if you see, there is a dirty gas which would generally as a property enter from down, and there would be certain spray nozzles which are there, and there will be clean gas going. So if you see, there is one direction in which the liquid which is in contact, absorbing liquid, would be flowing, and the dirty gas would be flowing in the other direction. So this is called as counter current gas flow spray, because both are opposite to each other. So here these are simplest devices consisting of a open vessel, and there will be a lot of spray nozzles distributed equivalently. Now the gas stream, as I mentioned, would be coming from here, okay, from the bottom and moving up, because the property of gases, since they are lighter, they would be moving up. And The liquid and gas streams as opposite referred countercurrent flow, and spray towers in this range particle size which could be removed are 0.14 to 2800 meter cube per minute. So spray chambers, they can operate in cross current or co-current flow arrangements as well when there is a limited space available. So in co-current absorbers, the gas and the liquid will flow in the same direction, okay? But then because the gas stream does not push against the liquid stream as in counter current flow, the high gas stream velocities can be used, and there is a little limitation in terms of the output or the efficiencies. The counter current are usually much more efficient as compared to cross current or co-current flows. Applications of the systems are where there is extreme solubility in the absorber of the gas which is to be treated. Next, high pollutant removal efficiency in this case would not be required. Third, chemical reactions in the absorbing liquid could result in certain salt formations which can lead to plugging. So these are some of the points to be considered. Now these spray towers can be used in number of flue gas desulfurization system, and the advantages are they are open, completely open. They have no external components except for the spray nozzles and connecting pipe. So coming to the next type of absorber systems, that is your packed bed absorbers. So over here if you see, there is some packing material. Okay. So packed columns disperse the scrubbing liquid over packing material, which provides them a large surface area for gas to liquid contact, which will help in better efficiencies. Now the packed bed, they are classified according to the relative direction of gas to liquid flow. So there are two types over here: counter current packed bed systems and cross current packed bed systems. So most of the times the counter current flow is used, as we have even seen with the spray towers that the efficiency is really good. So over here for the next system, again packed bed system, counter current flow towers are being used, the figure of which is shown here. So the gas stream being treated is going to enter from here, the bottom. Okay, the liquid is introduced from the top over here. The scrubbing liquid would be introduced. Okay, so the most dilute gases is put in contact with the least saturated absorbing liquid, okay, so that more absorption will take place. The concentration difference between the gas phase contaminant and the dissolved concentration of the contaminant in the liquid is at the top of the bed, providing driving force for continued absorption. So you will have the gas entering from here. There will be this packing support material through which this flue or a dirty gas would go. There is a liquid redistribution system so that evenly the liquid is distributed over here for the contact period. From here further you would have the flue gas moving up. Again you would have the contact period over here in this system. Here the liquid has been put in, which will be taken out or withdrawn from the bottom. So here one thing to be remembered is liquid in, liquid out, gas in from the bottom and gas out from the top. Now coming to the cross flow absorbers. They require complex design procedures because the concentration gradient exists in the two direction of the liquids, because it's going to be a cross flow. Okay. So from top to bottom and from front to rear. Here something to be remembered is gas phase static pressure drop over here is going to range from 0.06 to 0.25 kilopascal per meter of packing when the unit operation are typical gas flow rates. So large variation in the liquid or gas flow rates cause loading and flooding in this type of particular absorbers. So you would have the liquid which has been sprayed from the top, okay, whereas the gas is moving in this way. So this is like cross movement, okay, it's not in the direction, it's not counter direction. It's something like a perpendicular. When you will have a flue gas coming from here, you'll have the liquid being sprayed. So on this medium, there will be reactivity taking place. So that is where the flooding can occur.